Valid palindrome. Leetcode's 125th problem. So let's read through the description, solve this problem conceptually, and then implement that solution in both JavaScript and Python. So a phrase is a palindrome if after converting all uppercase letters into lowercase letters and removing all non-alphanumeric characters, it reads the same forward and backward. And here they're saying alphanumeric characters include letters and numbers. So given a string S, return true if it's a palindrome or false otherwise. And they've given us an example here, but we're not going to use their example because we have a way more fun example right here. So S equals yo banana boy. And we've got two non-alphanumeric characters in this string, these two spaces right here. So these spaces are non-alphanumeric. Therefore, we don't even want to consider them a part of our string. We actually want to remove them. So we want to remove these alphanumeric characters, and we want to convert all uppercase letters into lowercase letters. So we've got this uppercase letter here. We've got these alphanumeric characters, and we want to convert the uppercase to lowercase and remove the alphanumeric characters. So if someone said, hey, solve this in 2 minutes, and if you do it, I'll give you $100, how would you solve it? Well, I think most people would solve it in a relatively similar way. We'd look at one side of the string and the other and say, okay, if these were both lowercase, would they equal each other? Yes, they do. Let's move in. Okay, does the O match the O? Yes. Does the empty space, oh wait, it's an empty space. We're not even gonna look at it. We're gonna move on to the next one. Does the B match the next one? B, yes. Does the A match the, oh, it's an empty space. Okay, we'll move on to the next character. Yes, it's an A. And we'll keep doing this until either there is a character that doesn't match. Let's say that this N was like an F. In this case, this wouldn't be a palindrome, but it is, let me get rid of that because, oh God, it is an N. So let's just get rid of this here and pretend that this is still an N. And then we may end up, if the string is even, we will have no character in the middle, but if the string is odd, we will have this character in the middle. And it really doesn't matter what this character is, right? As long as it's a alphanumeric character, it doesn't really matter what it is, because the string is going to be a palindrome either way. So, for example, let's say that non was our string. We can tell that non spelt forward and backward is the same. We could change this non to a nan, and it's still a palindrome. So the middle character doesn't matter because there's not a reflecting character on the other side since it's in the middle. So now that we've done this conceptually, let's convert this into a more a more coding language friendly way of doing it. So I think the easiest way to do this is let's go ahead and convert this. Let's get rid of all of the non-alphanumeric characters and convert all uppercase letters to lowercase letters. So we would have then S equals yo banana boy. Oops. Okay, yo banana boy. All lowercase, got rid of all alphanumeric characters. Now we can do the same thing, and it's even easier. So we go through and we check, is Y equal to Y? Is O equal to O? Yes, and we keep going through. And if it wasn't, if any of these, again, if this was like a K, we would say, okay, we can automatically assume that this whole string is not a palindrome, because it really needs to reflect right down the middle. In this case, the middle is directly on the A, so all the characters need to reflect. And if one character doesn't, then we can assume automatically that it is not a palindrome. Okay, so that's how we solve it conceptually. Now, what's the space-time complexity here? So what's the space-time complexity? Well, the space complexity, since we are taking this string, right, our given string, and we're converting it, we'll call this this would be called like filtered string. We're converting it to this filtered string, this new string. That is an O of N operation. We're creating a new string, and the way that we're doing it is we're looping through all the characters in N, and so we're creating a new string that potentially could be of the same length. So this is going to be O of N, since we're, again, creating this new string based off the size of N. And then our time complexity, well, we're going through this initial string once to create the new string, right? So we have to loop through every character in the string. So that's N. That takes us N amount of time. And then again, when we do this check, we have to check at least half of this new string. So at least half of this new string. So that's half of potentially N, could potentially be N. And since we get rid of lesser terms, and we get rid of constants, since there's a constant here, the only thing left is N. Even if this was 2N, we would get rid of the constant and we'd just be left with N. So that gives us our answer of the time complexity. This is a time complexity of O of N, and that's our solution. That's our space-time complexity. All right, so let's solve this in JavaScript first. First thing we're going to do is remove any non-alphanumeric characters from our string and convert the string to be all lowercase. And we can use the replace method, which is a built-in JavaScript method for strings. And the first parameter, the first argument that we'll pass in is going to be a regular expression. And in this regular expression, we're going to say that if we come across any non-alphanumeric characters, we want to replace them with nothing. We actually want to delete them, right? So the way to say not, the way to negate something in JavaScript is using this caret key here. So this caret operator. And now we're going to say uppercase A through Z, lowercase a through Z, and then 0 through 9. So as we go through this string, any character that isn't one of these, we're just going to replace with this, with nothing, an empty string, meaning it's going to be replaced with nothing, therefore it's going to be deleted from the string. And we want to make sure to have our G flag added here, and this G stands for global, and it means that it won't just execute this regular expression on the first instance of the string. So let's say that S was equal to, P, Y, and then some non-alphanumeric characters, right? So and money sign, FH. So we're going through this s.replace is going through. It looks at the P, that's fine. Looks at the Y, that's fine. Looks at the and sign, and the and sign is not in this regular expression. It is not a alphanumeric character, right? So we are going to replace it with an empty string. So we get rid of it. And then here's a second instance of it. And so that's where this G flag comes in. This is our global flag to say, hey, for every instance of a character inside our string, we want to remove it if it's non-alphanumeric and replace it with nothing. And so once that's done, then we want to convert that string, because this dot replace is returning a string. We want to set all of the string to lowercase, right? So we will say to lowercase. And that is a built-in method as well. It's a built-in method for strings as well. So we want to set this to a new string. We'll literally call it new ns, or new string. New string equals s.replace, and then all the following. Okay, so now that that's done, we want to create a left pointer, or a left pointer, we'll call it LP. Set that equal to 0. We'll create a right pointer equal to our new string's length. So our new string's length minus 1. Then we'll start a while loop and say while LP is less than RP. So while our left pointer is less than our right pointer. And if that's true, we will check to see if the left pointer, if this element of the new string, so at left pointer, so this is going to be an element of this string. We're checking to see if this is not equal to the element of the string of the right pointer. We want to return false, because if these are not equal, then we know for sure that this is not a palindrome, right? So if we were looking at, as our while loop goes through, it checks this A on this left, and it checks this A on the left, and then okay, those are true, so it will move through the while loop, and we want to add actually LP. So our left pointer should get added 1 to it, should increment by 1, and then our right pointer should do the same, except it should decrement by 1. So in this case, now pretend we're going through the string, pretend we're JavaScript going through the string, and we're in the while loop. We check A against A. Okay, yes, those are good. Then we check the second character as LP gets incremented by 1. So we check the second character on the second iteration of the for loop. And as RP got decremented by 1, it is now in this position, and it's C. So A compared to C, these are not the same value. And since they are not the same value in this check where we're checking those elements against each other, this is going to return false. So that's how that works, and that's why that works. And so if we're able to go through the entire string, and there's no instance of two characters that are compared and they return false, then we want to return true. So we can do that right here, return true. And I think that this should work. So let's go ahead and submit this and see if it does. It looks like this NS needs to be an uppercase S here for new string, and here. Okay, let's go ahead and check. Okay, great. It works. Now let's go ahead and do this in Python. So the first thing we're going to do is create that new string that filters out all of the non-alphanumeric characters and converts all the characters to be lowercase. So we can use the regular expression module and the substitution function of this regular expression module. So usually we would actually import RE. So we're just importing the regular expression module from Python, and then we're using it here. And now we want to pass in three things into this function. We want to pass in the pattern, the regular expression pattern that we're looking to match. We want to pass in the string that we are going to substitute that pattern with, and then we want to actually pass in the string that we're running this regular expression function on. So the first thing we want to do is pass in the pattern. So what are we looking to replace here? Well, we're looking to replace any character that is not an alphanumeric character, and that would be any of these characters. So anything outside of the realm of A to Z, lowercase, A to Z, uppercase, or 0 to 9. Then the next thing we want to pass in is what we are going to replace those characters with. So any non-alphanumeric characters will be replaced with an empty string, not a space, but an empty string, meaning nothing is going to replace them, aka they're just going to get deleted and be replaced with nothing. Then we want to pass in S, because S is the string that we're actually calling this function on. And that's all we need to do for that. Oh, and we want to make sure to convert those characters, the returning string, we want to convert that to lowercase. So now we have a string that has only lowercase characters and all the characters are alphanumeric. Now we want to create our pointers. We don't use let. We just have a left pointer that equals 0 and a right pointer that equals n of s, or ns, new string, rather length of the new string, minus 1. Then we will create a while loop, and we'll say while left pointer is less than the right pointer, then we'll continue to check. We'll continue to do our logic, which is to check if the element at ns, so this element at the left pointer position, we're going to check if it's not equal to ns at the right pointer position. And if that's the case, we're going to return false, because if they are not the same, if they're not equal, we want to return false. Now, the reason for this is we can just look at this really quickly. AA, B, AA. I think we did this in JavaScript example, actually, so I won't do it again. But that's what we want to do. We want to return false, and then outside of the if statement, we want to then increment the left pointer and decrement the right pointer. So we'll do LP plus equals 1. So that's to say left pointer equals left pointer plus 1. And then RP, so right pointer minus equals 1. And that's the same thing, just in a different direction. So it decrements that pointer. And then once we're done with that, outside of the while loop, we will say return true. So if we've made it through the entire while loop, we checked every single character from the most outer on the left to the most outer on the right, and we went through it one by one and made sure that every step in, those characters were equal to each other until either there was one in the middle, or you got to the middle and there was literally no, it was an even length string, so there was no middle character. And so everything equaled each other. There was no time where a character didn't equal the other character on the mirroring end. And then we will return true. So let's submit this and see if it works. Okay, so we've got an error here. Looks like it's this NS. Should have a snake case on that. And there we go. So that's how you solve valid palindrome in both JavaScript and Python.